What is up, guys? Today I'm going to show you how to solve this silly little equation right here. Let's get into it right now. First things first, you're going to want to divide both sides by 2, because this 2 is hanging loose right here. We can move that to the other side and create 1/2. Wow-wee, look at that. That looks so much better than how it used to, right, guys? Anyways, from here, you're going to want to pull up a unit circle. So, if you remember the unit circle, you can remember that things right here look like they could fit in it. But what we're going to look at specifically is what's not in the parentheses. We'll worry about that later, because that looks weird. All we're going to worry about is this sign and this 1/2. If we can apply our super brainiac knowledge, then we can realize where that is on the unit circle. And sure enough, whoa, there it is. See how we find these coordinates, right? And they have 1/2 in them, and they're positive. Because we're dealing with sign here, we need to look for the ones that are on the right side. And look at that. Right here, you got a positive 1/2 on the right side. And right here, you got a positive 1/2 on the right side. So now what we do from here is find out how these coordinates connect to the radian. Oh, and look at that, guys. We remembered what radians match up with these coordinates. 5 pi over 6 and pi over 6. Now, because this is all solutions, these are the only 2 answers we're going to stick with, but there's a twist. We have to apply some more knowledge than just these radians, okay? So bear with me. Let's get into it. So, now what you're going to do is you're going to take 5 pi over 6 or pi over 6, whatever one, it doesn't really matter. Now you're going to add this goofy looking thing that says 2 pi k. And now what this is basically it's going to specify where on Earth on the circle is what we're looking at. Because since this is all solutions, it's basically a circle spinning around unlimited times. And this is going to help us narrow down like what on Earth we're looking at here. Remember that thing in the parentheses I said not to worry about? Now we're going to worry about it. See up here, it was in the parentheses pi over 4x. We're going to take that from the parentheses, bring it all the way down here, and make this whole shazazz equal that, okay? But now, of course, we need to get x alone to make this problem look a lot better. How are we going to do that? Since we got to get rid of that fraction, we got to multiply it by its reverse numerator and denominator on both sides, because we're applying everything to both sides of the equation. And what that's going to do is immediately cancel out that. But that leaves you with quite a mess over here, and we're going to get into that. All right, now what's tricky with this part is since the pi right here is the denominator, it's actually going to cancel out all of these other pi's in the equation. Why? I actually don't really know, but let's just go with it. So when you multiply 4 over pi by 2 pi k, it's going to actually just turn into 8k, because you're going to take the numerator and multiply that by that 2. Going to get 8. The pi is going to cancel out that pi, and then you're just left with the k value that's just unaffected by that. So just like earlier, the pi actually cancels out the pi that's in there already, and you're just going to multiply the numerator by the numerator and get 20. And that's going to leave you with something like this, except there's still one problem. Dun, dun, dun. Oh no! What is it, Aaron? Don't worry, I'll tell you. This 20 over 6 can be reduced. No way. And there you go. There's one of your answers. Now we actually have to go all the way back. And remember, when we got this pi over 6 from the unit circle, we got to do the exact same thing to that. Let's do it. So, of course, first things first, we're going to take that pi over 6 and add 2 pi k to the front. Remember, that's just to specify where the unit circle is. Then, remember, we have to take what's in the parentheses all the way from earlier. All right, and then it's the exact same ordeal here too. To get the x alone, we've got to reverse the numerator and denominator and multiply it. So you're going to take this 4 pi and throw that into the 2 pi k. And you're going to get 8k again because, well, the pi cancels out that pi, and then the 4 times 2 is 8. And the k is just left alone because you can't do much to that. All right, so you're going to throw that 4 over pi into that pi over 6, and bam, it turns to 4 over 6. Since that pi cancels out any pi in its way, and that 4 just will go over the 6 because the denominator can't really be touched. So you got 8k plus 4 over 6. And you might think that's the final answer, and wow, we am all done. You're wrong! You're so wrong, kid. Remember, this 4 over 6 can be reduced. Whoa! Ta-da! See? It could be 2/3. Whoa, now that's looking better. Since we got 2 answers now, we're gonna actually go ahead and put them together in the proper form. And there you have it, folks. That's what your final answer should look like. Alright, guys. We are back at it with a proof problem. And I know what you might be thinking. Ooh, that looks yucky. But don't worry, man. All we're trying to do is make this side look like that. Because we're proving that that side can equal that side, okay? So you might be sitting here thinking, but Aaron, what do I do? Be patient, okay? Be patient, you little child. All you need to do is get to your little cheat sheet. Look here. Cosine of A plus B? Isn't that what's right here? What? And what's this? Cosine of A minus B? It's right there. But they equal different things, different whole new things. What? From the information we were able to pull from here, we were able to actually take this cosine of A plus B and this cosine of A minus B, use this sheet and insert these big things into this big fat equation. All right, since these cancel out because one's positive and one's negative, you're just gonna be left with these two, cosine of A and cosine of B, plus cosine of A and cosine of B. Do you remember what that was supposed to equal from originally? 2 cosine of A and cosine of B? Wait, but there's one right there, and there's one right there? What? That could equal that? No way. Just equivalent to 2 of those, so 2 cosine of A cosine of B equals 2 cosine of A cosine of B, and there you go, dude, you just proved it. Way to go. That was so much fun. All right, well, I'm going to leave everything up to my buddy Ezra to help you out with the next 2 problems. You better be paying so much attention, okay?
All right, I'm going to be proving tan x plus pi over 4 equals tan of A plus tan of B over 1 minus tan of A times tan of B. In order to do this, I'm going to open up a unit circle real quick. Now, as we know, this point right here is pi over 4. We know that from our unit circle knowledge. And pi over 4 equals square root of 2 over 2 on both sine and cosine. Now, we need to find the tangent of pi over 4. So tan is sine over cosine, which means we end up with this jarbled mess, but it all just cancels out to equal 1. Because if we have one thing over the same thing, it is always 1. So we know that pi over 4 is equal to 1. So we can now rewrite our equation. Tan x plus pi over 4 equals tan of x plus tan of pi over 4 over 1 minus tan of x times tan of pi over 4. Now, we can simplify that even further to get our true answer, which is tangent of x plus pi over 4 equals tangent of x plus 1, notice how we substituted, over 1 minus tangent of x. And we didn't need to include that final tangent of pi over 4 because it would have just multiplied it by 1, which equals the same thing. So our final equation is this, and that is the proved function. All right, now for some easier stuff. We are solving 2 times sine of theta equals square root of 3. This one is actually pretty simple. First, you divide the 2 off of the left side of the equation, and you're just going to put it on the right. So you now have a fraction on the right side. So that would make the equation into sine of theta is equal to the square root of 3 over 2. Now, as we know, square root of 3 over 2 is a sign that we can find on the unit circle. So we are going to look to the unit circle, and both of these points have the sine value of square root of 3 over 2. That means there are multiple correct answers to this problem. We know this because we know the unit circle. Now, from there, all we have to do is move down the sine of theta from our original equation, and we now have the finished equation. Sine of theta is equal to pi over 3, as well as 2 pi over 3.